Ooh,
said.
rookie. Like swimming midair.
Yeah. Dude,
What?
look at these fucking images.
What about 'em?
They're so blurry. I should have used a PNG.
Are you serious right now?
What do you mean?
Well, you see.
So let's quickly break down how I will be showing you the difference between these two types of images, and then from there, we can then see how these different images can actually be applied properly. I will be using something called a difference layer or blending mode, depending on where you come from, what it goes by, what have you. So the way it works is that I have a couple examples here, and I will quickly explain each example so we can understand where it is. So with the first example, we have two individual circles which blend in the middle to meet this color. The way the difference algorithm works is it takes the two colors that are overlapping, and then what it will do is it will attempt to reach a median point. So for instance, if the circle on the left here is circle A, or color A, depending on what you want to use, and the one on the right is B, then we can see that if we grab this dot, which is using the difference algorithm, and we place it roughly in the center, about there is almost exactly what this color is. There's a couple differences, but if we very quickly, as an example, take two squares that are going to be the same size, we color match each section. So we will select U, and then we quickly color match the one right here. Doop. You can see that these two shapes, using the hex code right here, this hex code is 4D, 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 and this hex code right here is 424242. And that was just off of eyeballing it. So those are very similar numbers. They're not exactly the same. That is mostly due to my margin of error with selection, but I think it illustrates the point well enough. For the next value, we have two complementary colors that are not opposing each other. For this, we have the cyan again, that is about there, but this time we have yellow instead of red, which is about there. Because of this, this is where the layering is a little peculiar. The dot wouldn't go here because that is more relatively similar. Where it actually goes is it shoots across to the other side where the difference actually is. So a way to think about it is that if you have perfect hues, think about where the middle is, and then put it on the opposing side. Test 1 and 2. The first test I made is this rainbow image right here. The top image here is a PNG, and then the rest of these are all JPEGs, and we will be simply comparing them to the raw raster that I have right here. So right now, all of these layers are hidden. That's what these little dots denote. And then right here, the original, is the gradient that I made. So as an example, this little ring right here, you can see that this is a vector. So as an example, I can convert to curves, and then now this thing I can wiggle around and do whatever the heck I want with. I want to undo that because that will sully our results. Let's go from here. If we first compare with the PNG, here we can see the difference being applied. So you can see where these rings are, because we are going from a vector to a raster graphic, there's a difference. And then these sort of 6 tiles that you can see here are because of JPEG effectively trying to convert them to raster and doing a bunch of weird little things. Sorry, in this case, it actually is PNG. And if we zoom in, you can actually see on a pixel by pixel basis where the biggest difference actually is the edge, where that seamless edge is being converted from a seamless edge to a raster, or pixels, or what have you. So, first comparing the PNG, we have this, where the biggest difference is that the PNG stays relatively faithful to the outer rings. And the gradients, although there is a small difference here, with how dark it is, it honestly is not that bad compared to a lot of other forms of image compression. If we then compare with the JPEG, it looks very similar. The algorithm is a little bit more present. However, if we zoom in as well, we can see with the lines, almost the exact same thing. If we compare the PNG to the JPEG, it's kind of switching back and forth, you can see that the lines are actually almost exactly the same. They're very, very similar, and that's because both PNG, which tends to be a lossless format, and JPEG, which has a lossless option, should be relatively similar. Due to various compression algorithms stuff, they're not perfect replicas, and calling them lossless is actually a bit misguided. However, it still works well enough. Now, let us lower down to the JPEG
at 85% quality. It looks a little bit brighter due to the color differences. However, the only real difference here is around the lines, which is where people often complain about JPEG artifacting. And this makes sense because if we jump down to the 50, you'll notice it gets even worse, and the tiles from the background get a little bit more pronounced. Though, if we're being real, you can barely tell the background has changed. It's only mostly the lines here because of the way that the JPEG sign algorithm works. And then for fun, because why the heck not, here is the 0% algorithm. And so you can see they massively reduce the color depth in order to attempt to compress the image better. If we compare that to the original, whoof, that's a big difference. But now, what matters a lot here, and the reason for this test existing, is because this is a test that takes advantage of effectively the full color gamut that can be exported using effectively every single possible color, with the sharp rings on the inside to really stress test the compression algorithms. The reason this matters is because we can then look at the image and see the file size differences. So let's do that real quick. If we load up the images, which are going to be here, we can see, and that is actually not the correct space, so incorrect, code, website, project scripts, JPEG versus PNG, results. Here we are. So now where this matters is that if we then compare the file formats, I will simply jump to not by size, however I want list. We can quickly see that if we compare sizes here, this test is the rainbow test. That is what the name for this is. You can see here that PNG has a file export size almost 7 times larger than the JPEG size at 100% quality. And they both are extremely similar, and they have very little differences. If we, as an example, go back to the lines and zoom super close in, we can see that comparing the PNG to the JPEG, they are what I would personally consider to be identical. They are not identical, to be very clear, on technicality levels. However, to the eye, the JPEG does absolutely fine. And if you want a quote-unquote lossless format that actually cares about how much space you're using, you should always use a JPEG. Test 2 is a test that I call shapes. The reason why this test is important is because what it does more than anything is it stress tests the sharp intersection where like various lines and shapes meet. And in this result, we want them to be as crisp as possible. The less crisp, the worse it is. And this is also an important time to mention that I actually exported each one of these images in a true 4K 4096 by 4096 pixels. So now let's proceed with test 2. So here's the render. Using the SVG format, you can see that if we scroll into this triangle, it is forever sharp. And then the intersections where these colors meet, you can see they're all very, very crisp with no sharp details. And currently we are at like 23,000% zoom. You can't even see the rectangle of the viewport on that. So you can see this is a very crisp, perfect image test, what have you, right now. So let's compare to the JPEG and the PNG. So the first one on the list, again, is the PNG. We can see here, I will disable the difference first. We can see here that now if we zoom in, the point here is pixelized. The points here are pixelized, but the intersection is still relatively clean. And then the intersections over here, which I consider to be more of a stress test, a little messy. They don't meet very well, but the algorithm is doing what it's supposed to do, and it is compressing the image the best it can into a raster form, even though the SVG is probably less space than the raster, but let's not get into it. If we then compare it to the original image, we can see pretty much exactly what I'm expecting. The flat images, or the flat sections of color, are effectively identical, thus being what I believe to be a pure black. Yep, pure black. Oh wait, sorry, my bad. Yep, pure black. You can see right there by the 6 zeros. The 6 zeros denotes black, which basically denotes absolutely zero difference. Pixel per pixel, it is perfectly the same. And the only place there's an issue is on the intersections where it needs to be converted to a pixel and things don't meet perfectly, because that's just simply how the rasterization process works. You can see here all these pixels dancing around do not match perfectly, but that's simply how it goes. If we then compare that to a JPEG, oh, it looks very similar. If we zoom in again, you can see it's almost exactly the same. There's a little bit of what I'm going to call fireflies here, But if we're being honest and we turn off that, you cannot even tell that is a difference unless you're using a very high tier monitor or the monitor color calibration is insanely out of whack. And then for extra fun, what we will do is we'll test the other two levels, and this is where the difference between PNG and JPEG gets more pronounced. If we instead switch to an 85, and we zoom in, you can see now these edges all become kind of fuzzed. The edges lose their crispness. If we go back to the intersection over here, you can see this intersection kind of becomes a bit of a noisy mess. If we zoom out and kind of come into this corner, this point here managed to hold its retention pretty good. However, if we go to a more challenging corner, say here, same thing, a bit of a blurry mess. And if we compare it to the original, well, now we can see that these lines have become more pronounced. And then if we also zoom in, this goes to visualize the starking difference between the two. Because this is the JPEG algorithm doing its best to compare the colors, and this is often what people complain about. For fun, here's the 50% algorithm. You can see that those areas got much worse. The intersection here, if we compare it to the original, this intersection is not too bad. This point got effectively cut off due to the smoothing and the way that the algorithm is. This point right here is kind of just got blurred out. However, at a distance, it still looks relatively okay. And then lastly, we have 0% because, hey, why the heck not? Looks pretty good at a glance. However, if we look at this close up, it has these weird chunky squares now. It's now coloring the inside of the triangle here, or that point. This intersection is a blurry, chunky mess. They've added a bunch more shading here that never existed, and they're adding more detail to the image, which if you zoom out, makes all the edges kind of look weird and fuzzy. This is one of the strengths of PNGs compared to JPEGs. PNGs attempting to be lossless will do their absolute best to not change data in any possible way. And a JPEG set to 100% compression export will do the very similar thing. However, if you try to lower it to attempt to optimize file sizes, or you just leave it to auto, which is generally set to about 85 to 50, that will be an issue because it will start to mangle your images. It is simply how the algorithms work. And then for fun, here's the comparison of the 0% algorithm. You can see here that they actually started changing colors in comparison to the default algorithm, which effectively changed no colors. And the reason why is because with the default algorithm, it doesn't change the color depth at all. However, with the massively compressed JPEG compression, it will start to sacrifice color data to reduce the file size. So this all sounds terrible, right? Clear win for PNG, right? Well, this test, which I named Shapes, right here, this image just looked a little bit darker, which threw me off. We can see here by file size, PNG is once again the largest at 835 kilobytes. Then going down to 654 at JPEG 100% quality. For 85% JPEG, that size is reduced by effectively a third, going down to 400 kilobytes. Then it reduces even further at 50% to 214 kilobytes, and then down once more at 113. For this example, personally, I would not consider anything below JPEG 100 to be acceptable. So under this instance, I think it would be justified to use something like the PNG format. However, I think using the JPEG format in this scenario is still better because the differences between the images is effectively identical while having a reduced file size. For the next test, I have the skull painting that I did a little while ago. It is not a flawless version, however, it's good enough for the test. The reason why I want to include this test is for the example of something that is more illustrative, so you can compare the shading and whatnot. So, once again, we will first compare the PNG. Oh, asterisk. We're doing this now in Krita. The reason why we are doing this in Krita is because these images were exported via Krita. Before, I was using Affinity Designer, and I want to separate these across multiple applications so that the results are consistent and we are isolating any variables. So in this instance, because we have switched from Affinity to Krita, we can assume that if the pattern is consistent of PNGs consistently being larger than JPEGs, that we know that that is a consistency with the JPEG format instead of some special algorithmic thing that Affinity did for the image. So, same thing here. relatively large image. I'm not sure how large exactly. I forget exactly what it is. However, you can see the file size is about 403 megabytes. That's actually MB, but that's a whole other thing. Again, don't worry about it. Just pretend it's the same thing. It's definitely not, but just pretend. First, comparing against the PNG. I will hide that first so we can compare. Whoops! I'm used to the other file sorting formats. So we can see here with PNG, if we zoom in, compared to the original, let's just say the original, you can see here that like if I go into this area, which is relatively textured, kind of like in this eye socket area right here where the cursor is, you can see that the PNG is effectively identical. It does actually make these colors around here a little bit lighter, but I believe that is because the image itself was done in 16-bit color while the export was done in, so that will cause some slight changes to the artwork. Similar thing up here, all these details and textures. If we disable, re-enable, you can see effectively the same thing, a little brighter here, but outside that, effectively notable changes. Let's compare again with the JPEG. Very similar thing. You can see actually with the JPEG, there is a tiny bit of banding in here where it's a flat color. However, I don't actually expect it to come through on your guys' end because you're watching over YouTube, so it's been extra compressed, and I want to keep the changes more notable and obvious. So, we can effectively establish again that the 100% quality of JPEG compared with the 100% version of the PNG are to the eye effectively identical. If you really want to pixel peep, I'm sure you can find a difference. Or, to be lazy, what we can do is we can set the layers to difference, and then we compare. Check it out. This image, the original image, keep in mind, was a raster. So, you're simply translating a format to format, and you can see in this instance that the PNG is actually effectively identical. And if we compare to the JPEG, it is also effectively identical. And just to prove this is the case, what I will do is I will take the PNG, we will export this real quickly, just this black image. Stick with me now, this has a point. What I will do is I will just export it into, say, this random place for now. We will have large file size, so it's compressed, so it's lossless. Then what I will do is I will then take it into Affinity Designer. I will then go, actually, I want a photo. So here is that exact same black image from Krita that we just exported. The reason I'm doing this is just to prove that it's not bugging out or doing anything weird or unexpected. Just to prove that this is actually working. If we simply go here, we go to Filters, Colors, I guess I can do all. We can see here that you actually have the silhouette of the skeleton here, and then you have the background right here. So you can see there's a difference, and this is a difference, the difference between the PNG and the default raster. These are the very subtle changes that the PNG format is making to the image compared to the JPEG. The reason why I want to show that is to prove that this is not bugged. It is actually still working as intended. And we can see, going back to Krita, that is the case. And in this case, once again, the JPEG and PNG are effectively identical. And the reason why I mention this is because if you can't see it here with a filter that is literally designed to enhance the differences between the two, they are effectively identical, and you should treat them as identical, meaning that in this scenario, the only reason you should be choosing a PNG or a JPEG over the other is file size, because at the end of the day, data is not free, and having the ability to change, to reduce your file size but have the same visual quality is incredibly important. And the exports of your project are not archival formats. The only thing that is archival is the actual save file itself. So if you care about your artwork, then you need to back up the save file, not the export that you did of it. Carrying on further, we can see comparing to the 85 PNG, 85% quality PNG, it is effectively the same because PNG actually isn't supposed to have quality versions. If you see a quality slider on a PNG, that is not actually a quality slider, that is a compression algorithm and basically how hard you're hitting your CPU. So if you actually want your render to take longer, simply set it to a worse compression algorithm, or vice versa, depending on the software. And we can see that because 85, 50, and 0 of the PNG format all look identical. However, if we switch over to JPEG to 85 as an example, we can see still very similar, but if we zoom in, we can start to see some little differences, like in this cursor here. If you have a monitor that can show it properly, you can see here some small differences. And if we jump to 50, it'll be even more pronounced. Whoops, that is the PNG, I apologize. There we are. So now, finally at 50% compression with JPEG, we are starting to notice a little bit of ghosting with the image barely starting to come through. Then, just for the lulls of it, if we then reduce it all the way to 0%, now we can finally see a big difference being made. And that is cyberpunk as fuck. I actually really love the way this looks. And just for the example, here is the JPEG completely compressed, maximum compression. Being real, I love the way it looks. Wouldn't look good on everything, but I think it looks good here. And if we were trying to compare to the original image, this would obviously be a clear failure. However, I think it is note it can be fun to play with stylization in this way. Going back, however, to comparing to the original image, we can finally see here, now there is finally starting to be some big differences. However, with this image that has more complex shading and detail, that the difference is effectively null with the higher format or the higher resolution JPEG PNG stuff. If we then jump to the files, the exports that we did, and we compare to the results, and we sort by list view so we can see by size, we can see here the PNG versus the JPEG. The JPEG is almost 1/3 the size, once again, from the PNG. If we then compare further, the 100% PNG compared to the 85% PNG, compared to the the 50% PNG, compared to the 0% PNG, all are effectively random numbers. And the only thing that I can think of that would make a notable difference on that is things like metadata. However, if we then compare to the JPEGs, we can see here that the 100% quality JPEG is 1.3 megabytes. The 85 is 298 kilobytes. The 50% compression is 149 kilobytes. And then the 0% compression or quality, I've been kind of saying that backwards, is only 34 kilobytes. The JPEG here, under this instance with a painted image, for me, is an absolute clear winner. The next example I have is a while ago, I went to this carnival with my family, and I took some photos with my camera there. It was shot on the Canon T6i, and once again, I'm going to be showing you the various compression versions. The CR2 here is the source file. That is as good as it can get. That is a quote-unquote lossless format, which actually has extra data, so that's cool. Purpose being for photo editing content. Once again, PNG, and then the JPEGs below there. So, if we going through the same song and dance again, if we compare the difference, the PNG is effectively identical, which is what they advertise, lossless. If we go one lower to the JPEG, once again, lossless. The differences are negligible to the eye. If we then compare a little bit further to an 85, still looks effectively the same. If we zoom in real close, we can see some subtle changes here and in here. If you can't see it on your monitor, that might just be because of color grading or how your monitor is calibrated. And then if we jump to the 50%, that is the only time where we can start to notice a bit of a difference with the image, seeing some very subtle ghosting of the differences between the image. And it's not until we get down to the extreme 0% that the differences become much more pronounced. Once again, same song, same dance. So, once again, let's compare the file sizes. This one is named Carnival. We can see that the PNG export is 113.1 megabytes. That is a lot for this image. To be fair, this is effectively a 6K image because that is what my camera shoots at. It's something like 6,000 by 4,000 pixels, but a little bit weird because of course it is. And then the JPEG version, which is effectively identical, is only 16.5 megabytes by comparison. The comparison PNG that you see right here, if we drag that into a new layer, what this is, same thing. So this is a comparison that I made and exported earlier for a test to make sure I wasn't going crazy. But if we just select auto levels again to crank it, we can see that it's still the image. There is compression being done, but the compression that is being done is so negligible that we can't actually properly see the difference. So once again, going back to the image, 85 goes from almost 16.5 megabytes down to 2.8. That is 1/8 the size for what is effectively an invisible difference. Unless you are really pixel peeping this image, it does not matter. Compress the image more. It makes way more sense. And again, if you are trying to save this to pass it around later, you need the source image. Unless you have the source image, it is not the original. And then for fun, the very terrible quality 0 zero quality level for the JPEG slider is only 187 kilobytes. It is tiny. Even if you want to jump up to, say, the 50, which at a glance for something like social media is perceptually the same when it's zoomed out like this, compared to the original, is insanely reduced. So keeping in mind that there's roughly 1,000 kilobytes to make up a megabyte, meaning 1,000 megabytes has roughly a million kilobytes in it, that ends up meaning that the difference between the original JPEG and the 50% JPEG is effectively a 16 times file compression ratio size. Lastly, what we have here is we have this 3D render that I made of my Sona a few years back. I like this image because it has a lot of detail, some cartoony, stylized, sharp edges, comparing harsh contrast with some more detail shaded areas. This was rendered in cycles if you're a Blender user, but has some cartoonish flares here and there. Once again, this is in 8-bit, and I'll be comparing to the PNG, so we can see the actual difference between a quote-unquote 100% perfect quality PNG compared to the JPEGs. So here we see the JPEG compared to the PNG is effectively identical. There are some very small differences, as we can see, but these differences are so small that, personally speaking, I would not consider them to be anything extreme or even worth worrying about. If we jump down to the 85, the top one is a PNG, the bottom one is a JPEG. The 85% quality PNG to the 85% quality JPEG, as we can see, is identical. There's no noticeable blotching anywhere. This is a pure black void. If we then compare that to a JPEG, okay, there's a little bit more differences with these lights in the background. You can see that sharp edge is where it definitely suffers a little. The silhouette of this character is coming out more, so on and so forth. However, once again, back to 50% PNG. The 50% PNG, effectively identical, and the 50% JPEG from the 85 is almost identical. The edges are just a little bit worse. And then comparing the 0% PNG to the 100% PNG, identical. And then once again, the 0% JPEG compared to the 0% JPEG compared to the other one seems to be oddly identical. So I think this might actually be a render issue. So do not count the JPEG here as anything valid. However, if we do compare all of the images, so we have image 1, the PNG at 100%. We then have the next one, or sorry, the JPEG at 100%. We have the PNG at 85. We have the JPEG at 85. We have the PNG at 50, the JPEG at 50, the PNG at 0, and then what is supposed to be the JPEG at 0. However, I believe there was an error. Being completely honest, I do not believe many people, if any, would notice any difference between these images, especially when you compare that to something like passing it over after compression and all these other things. I have noticed one place of consistent sort of weirdness, which is here. However, I do not actually believe that that is the image compression formats. I believe that is actually the Blender denoising, because this has an atmosphere applied to it, and I believe that this is Blender doing its best to smooth that out. So I would see that as a Blender rendering artifact that I missed until now, in comparison to actually being something concerned about. So once again, we'll go to Finder, and we will go to List View, and we'll compare the sizes. And we can see here, once again, the PNGs here all are 2 megabytes, which implies that the quality slider did absolutely nothing, and was simply comparing the differences between the files. If we compare the 100% quality JPEG, that's 821 kilobytes. I should mention, for an asterisk, this image is a 1080p image. The 85% render reduces that by almost 7/8 and reduces it down to 150 kilobytes. Going from the 85 to the 50 then reduces it by almost half, and then reducing it there further seems to, I believe, be a bug, and I believe, given these file sizes, that I accidentally exported the 0 as an 85, so we will have to ignore the results of the 0 here. However, with that being said, once again, comparing the 100% to, say, the 85 to, say, the 50, there is very little difference, and until you get to about the 50% compression range, I would be extremely skeptical of anyone claiming they can notice a notable difference unless they are zooming in a lot. However, on social media platforms, due to the nature of them, it is extremely short throw content, and you will be lucky to have anyone view your content for more than about 5 seconds from my experience, unless it is a different format like a video, speed paint, or something like that. So what is the message of this video, so to say? The message of this video is that, as the names imply, JPEG is much better for full images. Images where you do not need transparency, and images where you want to retain as much detail as possible. PNGs, however, are better for large flat images, such as comics that generally do not use shading, and things of that medium. If you are getting fancy with your comics and using cell shading, or the little dimple shadings, I forget what it's called, then you will want to use JPEG. If you're doing cross-hatching, you want JPEG. If you are doing any sort of complex shading in a painterly style, you want JPEG. The only instances where PNG, from my experience, is a superior solution is if you need the alpha, aka the background, to be transparent, or you are dealing with large surface areas that do not have any form of gradient or noticeable detail. If you are doing effectively anything else, please use a JPEG. I hope this video could help clear some air about the file formats, the differences they can make, how they are different, and various other little details like that. I hope they help you save space on your drive long term, and I hope that you can make the storage space that you have on your system go further. If you want me to do a deeper delve into other videos, hey, let me know. I don't mind. And if you found this video interesting, please leave a like, subscribe, all those other little fancy things. Hope you enjoyed. Have a great day, and bye-bye.